Hello everyone, my name is Kailash Kumar Subramani. My student ID is 2016-82375. My topic for my MSc project and dissertation report is Contrastive Explanations for ChatGPT, and my primary supervisor is Professor Prachita Sen. Table of content. Here we're going to talk about the introduction, the problem statement, project objectives, methodology overview, detailed methodology, user interface mockup, data source, testing, evaluation criteria, ethical concerns, project plan, risks and contingency plans, expected results, conclusions, questions and discussion. Introduction. Background, we're going to discuss the general concept of natural language processing and its applications. We're going to briefly mention the emergence of language models like GPT-2 and the impact on the field. We focus on an idea called contrastive explanations to sort out the many choices that go into language modeling. This method looks for input tokens that stand out and explain why the model made a certain guess instead of another. It is shown that these contrastive explanations are better at validating key grammatical facts than explanations that don't use contrast. They also make it much easier for people to mimic the model's process of making decisions based on difference. Project overview. Introduce the project by stating its primary goal. We are going to gain insights into GPT-2's behavior using the benchmark of linguistic minimal pairs using the BLIMP dataset. The significance of the project. We're going to be discussing how this project can contribute to the existing body of knowledge in NLP, particularly in understanding and improving language models. Take ChatGPT as an example of a language model. We can figure out why the model choose one token over another by giving two different reasons. This is especially helpful for making the model easier to understand and figuring out what the most important things are and how the model makes decisions. Problem statement. We highlight the complexity of interpreting the behavior of advanced language models like GPT-2, which can sometimes yield unpredictable results. The core issue being in research to understand why GPT-2 makes certain predictions when using the BLIMP datasets. We touch on how the problem affects the wider domain of NLP and the potential benefits of solving it. We succinctly outline the goal of our research to improve our understanding of GPT-2 predictions through different interpretability approaches, thereby enhancing the effectiveness and reliability of such models. Project objectives. The first objective is to gain a deep and detailed understanding of GPT-2's decision-making process. Here, we will utilize the BLIMP dataset to generate linguistic minimal pairs. By evaluating how GPT-2 responds to these pairs, we hope to uncover insights into the model's operation. The third objective is to apply various explanation methods like gradient input, contrastive gradient erasure and contrastive erasure to the model's prediction. By comparing these methods, we aim to find the most effective technique for interpreting GPT-2's choices. To better explain what a language model LM is doing, we suggest using contrastive explanations. It unravels the intricacy and illuminates the model's decision-making process. We intend to illuminate the black box nature of language models by concentrating on noteworthy input tokens that explain why the algorithm chose one prediction over another. Our final objective is to test the stimulatability of GPT-2 by human users with the help of explanations generated. Methodology overview. Here, we present the framework of our methodology, emphasizing on the interpretability approaches to understand GPT-2's behavior with the BLIMP dataset. Data. Here we briefly mention the BLIMP dataset, explaining its relevance and importance in our research. Interpretability approaches. We highlight the different uses, the approaches such as gradient input, contrastive gradient, erasure and contrastive erasure. We explain that these methods aim to give insights into the model's decision-making process. Evaluation. We introduce a plan to evaluate the success of these methods through user studies comparing the efficacy of different explanations provided by the model, and our outcome being we'll get a summary of our expected outcome stating that we aim to uncover which methods of the best interpretations improve our understanding of GPT-2. Here I'm going to explain my methodology in detail. A methodology starts with the selection of the BLIMP dataset. It is a collection of linguistic minimal pairs that we use to test the decisions of GPT-2. Here we apply 4 different explanation methods to GPT-2. These methods include gradient input, contrastive gradient, erasure and contrastive erasure. Using the explanations generated, we then test the simulability of the GPT-2 model. We present the model's input sequences, output explanations and 2 token options to users, and they choose the output that they think is more likely. The selected explanations are evaluated based on user feedback and accuracy metrics. Finally, the results are analyzed to draw conclusions about GPT-2's decision-making process and the effectiveness of the various explanations methods in making the model operations understand to human user interface mockup. Given the technical nature of the research, we've chosen to focus on understanding the GPT-2 model's decision rather than creating an interface. As GPT-2 is a backend engine used in a wide range of applications, the UI can significantly differ depending on the specific applications. Therefore, a UI mockup is less relevant to this study. For this study, we used the benchmark of linguistic minimal pairs, also called the BLIMP dataset. The dataset's use is governed by terms and conditions set by its creators. We've compiled with these terms and conditions, and we're committed to use these datasets for advancing knowledge in the field of NLP without misusing or misinterpreting the data or its results. All data processing conducted on this dataset as part of our research will adhere to ethical research practices and data management studies, protecting the privacy and confidentiality of all involved information. Testing. Here, we designed a user study testing model with different explanations. Users are given with a GPT-2 model's input sequence, 2 token options, and the model's output explanation. Users that select the more likely model output and indicate whether the explanation helped with their decision making. Our study compared different explanation methods: gradient input, contrastive gradient, erasure and contrastive erasure. The test will ask users to distinguish 20 pairs of highly confusable words. The user study include 10 ML students who each annotated 10 word pairs, with each pair having 40 sequence and randomly generated explanations. All the testing procedures will be conducted ethically, respecting participants' rights and privacy. Evaluation criteria. The success of our model is determined by its ability to simulate behavior accurately. We measure the percentage of users who found the explanations helpful in understanding the model's decision. As part of the evaluation, we will also collect subjective user feedbacks. The qualitative input will help us assess the effectiveness and usefulness of the system from the user's perspective. We'll use research and statistical models to assess these criteria. Linear mixed effect models will account for variability in annotator skill and word pair difficulty. Evaluation will be carried out by ML's graduate students who are not involved in writing the paper, ensuring an unbiased assessment. This will simulate model behavior and evaluate the assessment. And ethical concerns. We are committed to respecting privacy and copyright laws. All publicly available datasets that we will use will be properly cited. User research will generate new data. We will fully explain the tasks, data usage, and secure consent from participants before beginning the research. We will be transparent about all limitations and flaws in our testing and evaluation results. All data will be anonymized, stored securely, and accessible only to the research team. Data will be appropriately disposed of after the study. We ensure that the participants in our study are not harmed. If unforeseen ethical issues arise, we will discuss them promptly with our supervisor to ensure our study continues to maintain high ethical standards. Project plan. As you can see here, I have made a Gantt chart to keep track of my progress, and it clearly shows that I am up to date with the development and specs and design, and my next milestone is the design report and presentation slides. Once I'm done with this, I will move to the implementation and testing of my NLP project. Risks and contingency plans involve hardware failure, software failure, running out of time, programming problems, misinterpretation of results, NLP model failures, and data quality. Expected results being, we anticipate that these contrastive explanations will aid users in simulating model behavior, meaning they can predict the model's output more accurately. According to our expectations, these explanations should be more accurate and helpful than non-contrastive ones. Based on user feedback, we aim to refine our process and improve the usability and effectiveness of the explanations. Our primary success metric is the improvement in model simulation accuracy and user feedback, indicating the increased usefulness of explanations. In the long run, we expect this research to contribute to the understanding of how AI models think and make decisions, making them more interpretable and trustworthy. In conclusion, our research could advance understanding of AI language models and contribute significantly to the field of NLP. Future work could explore the application of these contrastive explanations to other machine language models and tasks, extending other interpretability methods to the contrastive setting, as well as using what we learn about models to contrastive explanations to improve them. Thank you so much. I look forward to our continued exploration in the field of NLP. I'm open to any follow ups, inquiries, and discussions.